In this chapter we'll be focused on vectors, mainly what is a vector, vector notation, parallel vectors, inverse vectors, addition, multiplication, and the length of a vector. A vector is a quantity which has both size and direction. For example, a car travels with 60 km per hour due east. We are using vectors in order to describe the direction of one point relative to another. Similar idea was with bearings, but bearings can only be used in 2 dimensions, where we was using degrees and the north line as the reference point. On the other hand, we can use vectors to describe the direction of one point relative to another in more dimensions, in 3 or even more than 3 dimensions. And we are using the column vectors x, y, where x represents the direction in the x-axis and y represents the direction in the y-axis. For example, if we're at the point A and we would like to describe the direction to the point B, starting from anywhere, where is the point A, moving to the point B, in that direction it's given by the notation AB, which means that you start from A and ends up at B, and since B is 3 squares to the right of A and 2 squares up, we write that the vector AB is 3, 2. Note that this is not a fraction, it's a column vector. Example 2, 3 means 2 to the right and 3 upwards. Minus 1, 4 means that move 1 to the left and 4 upwards from the relative position. 5 minus 3 means 5 to the right and 3 downwards, and minus 3 minus 2, from the relative position you have to move 3 to the left and 2 downwards. Note that the starting position is not that important in vectors, is the direction. We need to write the column vectors that represent the following directions from A to B. This means starts from A going to B, you have moved 1, 2, 3 to the right and 1, 2, 3, 4, 5, therefore the column vector will be 3, 5, and C to D it's minus 3, 2. Example 3, if A is the point with coordinates 2, 3, and we need to find, and we are given that the vector AB is 2 minus 3, that means 2 to the right and 3 downwards, we can find the coordinates of B. So starting from A, moving 2 to the right, 3 downwards, we go to the point B, which has coordinates 4, 0. Now, what are parallel vectors? 2 vectors are said to be parallel if they have the same direction, and one vector is a multiple of the other. For example, A and B means move 3 to the right and 2 downwards, where C and D means 6 to the right and 4 downwards. You see that these 2 vectors, they're going to be parallel. Maybe have different starting positions, but by moving 3 to the right and 2 downwards and moving 6 to the right and 4 downwards, these 2 vectors they will be parallel. And one will be a scalar multiplication of the other. We see that the vector C and D is 2 times more the vector A and B. Thus, we will only be labeled 2 vectors with the same letter if and only if they are parallel to each other. So different vectors will have different names unless they will be parallel. If they are parallel, we're going to use the same name, and one can be a multiple multiplication of the other. So if A and B is 3 minus 2, starting from A, going 3 to the right and 2 downwards, you go to A and B. The question is, what is the vector BA? BA means now you start from B going to A, and that will be minus 3, 2. Thus we see that if we call A and B to be the vector A, then BA is parallel to A and B, but moving in the opposite direction. So we're going to call this to be minus A. Note, if you are moving in the opposite direction of the arrow, you change the sign of the vector. That will be important in the next video, where we'll be using vectors in geometry. So BA is equal to minus A and B, and those are called the inverse vectors. Addition and subtracting vectors. If we are given that the vector A and B is 3 minus 1 and the vector BC is 4, 2, then if you start from point A and you go into point B by moving 3 to the right and 1 downwards, and now starting from B and going to C by moving 4 to the right and 2 upwards, then we see that we was at the point A and we end up moving in this direction. We end up moving from A to C in this direction here. And if we find now the vector A to C, we have moved 1, 2, 3, 4, 5, 6, 7 to the right and 1 upwards. So 7 to the right and 1 upwards, we can see that we also get the same answer by adding the movements in the x-axis and by adding the movements in the y-axis. So by moving 3 to the right and another 4 to the right, we end up moving 7 to the right. We are moving 1 downwards and 2 upwards. We end up moving 1 upwards in the final position. So addition of vectors just means what will be the final direction. In general, it's important to see that the vector A to E is starting from A end up to E is the same as starting from A going to B, then from B going to C, from C going to D, and from D goes to E is the same as starting from A and end up to E. Multiplying vectors, the vector 3A is a vector which is parallel to A but is 3 times bigger. For example, if we are given that the vector is 2, 1, means moving 2 to the right and 1 upwards, the vector 3A will be in the same direction, but multiplying 3 times more. So instead of moving 2 to the right, we are moving 6 to the right, and instead of going 1 upwards, we are going 3 upwards. So it's like we multiply each coefficient in the column vector by the number 3. So 3 times 2 gives you 6, and 3 times 1 gives you 3. You see that the two vectors are parallel and one is a multiplication of the other. Now addition of vectors and multiplication as a mixed exercise. 2a plus 3b, this means 2 times this column vector plus 3 times this column vector. So by doing the Beatmans, we multiply this column vector by 2, so we get 6, 12, and we add 3 times to this vector, which is minus 3, minus 12. And now the final position would be 6 to the right and 3 to the left. You end up being at 3 to the right. And 12 upwards, 12 downwards means no movement in the y-axis. We can also multiply vectors with a fraction. So 2/3 of A just means you multiply each number by 2/3. So multiplying 3 by 2/3, that will give you 2. And the number 6 by 2/3, that will give you 4. And minus 2 times minus 6, 7, we can use the minus here to become plus 12, minus 2 times 7 to give us minus 14. And if we add now these two vectors, it means we went 2 to the right and another 12 to the right, it's being 14 to the right, 4 upwards and 14 downwards, we end up being 10 downwards. So that would be the final column vector. So far we refer to vectors, but this is just a direction. The question is, what will be the size of the vector? So how can you find the magnitude of a vector? For example, the vector A, B. So starting from A, going 3 to the right and 5 upwards, what would be that distance now? Well, this is just Pythagoras theorem, where you move 3 to the right, 5 upwards. By using Pythagoras theorem, we can find the distance of the vector AB. So x is the square root of 3 squared plus 5 squared. And this will be referred as the modulus of a vector. So if a vector is given by x, y, the modulus, therefore the distance of the vector A, is represented by Pythagoras theorem, the square root of x squared plus y squared. Modulus means the distance, the length of a vector. Exercise, we need to find the modulus of the vector given that A is minus 2 minus 4. This means starting from a point, we are going 2 to the left and 4 downwards. So the absolute value of A is starting from A, going 2 to the left, 4 downwards, you need to find that distance. By using Pythagoras theorem, you move 2 to the left, 4 downwards. So the answer for the distance A and B will be the square root of 2 squared plus 4 squared, which is 4.5. Note, we could use this number here in the column vector of A, but without the sign, because sign just shows direction. So for the vector b, the distance of the vector b, that will be the square root of 5 squared plus 3 squared. So this means 5 to the left, 3 downwards. Using the triangle is the same as finding the distance of 5 squared plus 3 squared and then square root, you get 5.8. Now for the part C, where it is the absolute value of 4a minus b, first we need to find this as a single column vector, so find the direction of that vector and then use Pythagoras theorem to find the distance. So as before, we need to find what is 4a minus b, and 4a minus b means 4 times the vector a and subtract the direction of b. Therefore that will be minus 8 plus 5, and that will be 4 times minus 4 is minus 16, minus 3 is plus 3, so the final direction is minus 3 minus 13. The distance now of this vector, 4a minus 2b, will be the square root of 3 squared plus 13 squared, and we get that the answer is 13.3.